the first thing you need to do, the very most important thing, is understanding the problem. Yes, I can. Hold on one second. Okay, so what do we need to do? We need to read it. Read it carefully. Okay, here's where I changed step 2 a little bit. For step 2, she says you want to devise a plan. Hold on. You want to read the problem carefully, but here's where I changed things up a little bit. Okay, we're going to write down, we're going to take the information out of the word problem. Okay, rather than trying to deal with it in the word problem. So you want to write down what you know. And then you also want to write down what you don't know. That K is awful. And this is what the problem is asking you to find. Okay. Once you've taken the information out of the problem, it's easier to deal with, because then you're just dealing with like a list of numbers. Like, let's say it's a problem about, grocery shopping. Rather than having a whole paragraph, you just have like a list. Apples, 50 cents. Bread, $1.20. Just very simple. It's easier to comprehend and deal with the information that way. And then we need to devise a plan. Draw a picture. Make a table. Make a chart. Cross out unnecessary information. Because sometimes they do that too. They throw in a bunch of information that you don't need to solve the problem. Just cross it out. Also, you can plug in, like, I'm going to put in quotes, real values. And what I mean is, if you have an unknown and you're trying to figure out what are you supposed to do as far as working the problem, throw in some random number for that unknown. Just say it's, 10. And then try to work the problem out like with the 10, and then it'll help you to figure out what steps you need to take to find the actual answer you're looking for. Step 3, we're going to solve the problem. And then step 4 is to ask yourself, does the answer seem reasonable? Okay, if you're solving a problem for how fast a car was going and your answer is 325 miles per hour, does that seem reasonable? No, right? Maybe if you're solving a problem for a car in a race, but even then that's a bit high. But if you're talking about, someone who's driving from Albuquerque to LA and they're not going 300 miles an hour. They're probably going like 60 or 70 or 50 or something, right? So if your answer seems really out there, go back and check your work. Sometimes you cannot solve the problem as it's given to you. There's missing information. A man purchases 5 shirts, each at the same discount price, how much did he pay? What's missing? The price of the shirts, right? We don't know the price of the shirts. We can't solve the problem. Your bill was $20.36. How much change should you get back?
How much you're paying.
Right, how much did you give her? Did you give her 30? Did you give her 40? Did you give her a 50? Did you give her 25? Who knows, right? So you need to know how much. Right, okay, so sometimes if you have information missing, you need to be able to recognize that as well. Okay, so we're going to take the information out. This is how we do this, okay? So this is our no chart. You don't have to put a no on there normally, but I'm just, okay, we know that the roll has 100 sheets, and that it's $1.38, and this is for Easy Wipe, so there's 2 different brands. And that we know that the other brand has 5 dozen sheets. So 5 dozen sheets is
5 times 12 is 60.
Yeah, so 60 sheets, and it's $1.23. That's quick clean. And then we also know that you need 3 rolls of paper towels. Okay, this is what we know, and what we don't know is we want to find out better value. That's the question. What information does not matter? Okay, we need to figure that out. If this has 100 sheets and this is $1.38, that's important. This roll has 60 sheets and it's $1.23, that's important. I can use this information to find out the price per sheet. Do we care that I need 3 rolls? No, that's excess information. Nobody cares about that. To find out the better value, we're going to divide the price by the number of sheets. So it's about 1 cent a sheet. And that's about 2 cents a sheet. So who's giving you the better price? The one that's only 1 cent a sheet. So that was Easy Wipe. It's the better value. Packages is apple juice boxes and bottles. Okay, we have a 128 ounce bottle is $5.39. And 9-pack of 6.75 ounce is $3.15. Okay. None of this is unnecessary. Maybe you don't need to know that it's bottles and boxes, but you do need to know the ounces and the price. And here, to find the total ounces, I do need to know that there are 9 of them in there. So first I'm going to take and find what the total ounces here is. So I'm going to do 6.75 times 9. So that's the total number of ounces. And then I can take each price and divide by the number of ounces. Okay, what's a better deal? The big bottle or the juice boxes? The big bottle. better deal. You're buying a bike, and it's $680. That's a very nice bike. All right, and you're gonna pay $100 up front, and you're gonna pay $20 a week. So the bike is $680. Your down payment is $100, and your payments are $20. Okay. And we want to know how long till paid off.
19 weeks.
Nope. Unless I did my
What
division.
is going on?
Or excuse me, 29 weeks.
Yeah. So I paid 100, right? Already. So this is still owed. And you're going to divide that by $20 a week, right? And that's 29 weeks, or if you want, you can convert that to months, and so you're going to get 7.25 months. But either answer is totally acceptable. All right, we're programming a gate for a 50-cent toll. The gate needs to accept exact change only, right? It's not going to give you change. You guys have gone through tolls. You just throw the money in the basket, and it won't take pennies. So we have to program all the coin combinations that will be accepted. And then we need to figure out how many coin combinations must it accept. So first of all, what coins can we use? Okay, we can use quarters. You guys are forgetting one. $50.
People still use half dollars.
Yeah, you can still use them.
Well, of course you can still use them. Still make them.
Yep, they still make them. Okay.
Pretty fancy little board you have going on.
Draws much better lines than I do. Okay. If I use a $50, I'm not using any nickels, dimes, or quarters, correct? Alright, so that's one combination. If I use 2 quarters, no dimes, no nickels, no $50. How about if I use 1 quarter? What else can I use? I can use 2 dimes and 1 nickel, or I can use 1 dime, 3 nickels,
3 nickels.
or I can use no dimes and 5 nickels, right? Okay, let's say I don't have any quarters. How many dimes can I use? Which would give me how many nickels?
0.
Or if I only had 4 dimes, how many nickels would I need?
2.
If I had 3 dimes?
4.
If I had 2 dimes? If I had 1 dime?
8.
And, oh, I'm out of room. Here, I'm going to do like a little. And if I had no dimes? 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible combinations. Okay, I'm going to show you how to do this by diagram. And then I'm going to show you how to do it using straight math. Okay. All right, so we have 4 runners in a 1-mile race. Maria, Aretha, Thelma, and Debbie. We're just going to use letters for them. That way you don't have to write as much. Okay. Points are awarded only to the woman finishing first or second. All right, so we want to know how many arrangements of first and second. Okay. Well, Maria could come in first. Aretha could come in first, Thelma could come in first, or Debbie could come in first. All right, this would be first place. Actually, I'm going to space those out a little better. If Maria comes in first, who can come in second? Okay. If Aretha comes in first, we have Maria, Thelma, or Debbie. If Thelma comes in first, it could be Maria, Aretha, or Debbie. And you can see that they'd be mad that Thelma came in first. And if Debbie came in first, we could have that. These are all of the combinations. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Couldn't you just do
Yes.
4 people and then there's 3 other people?
Yes,
So
that's what I was going to say. That this is with a diagram. If you wanted to do it mathematically. No, you're good. You're just a step ahead of us. So if you want to do it mathematically, right? You have 4 people possible for first place. Which leaves you 3 people possible for second place, right? Okay. If they also wanted to ask you third place, how many people would be left for third place? 2. Times 2, so there'd be 24 possibilities. And then there's like 1 person possible for fourth place, so if you multiply it again, it's still, there's 24 total possibilities for the order of the race. Does that make sense? So you just take the number and go down by 1 each time and multiply them together. As long as nobody can be repeated. Okay, we'll go back. A sales director, he lives in City A, so this is his hometown right here. He has to fly to all these different offices. And there are no restrictions on the order in which he goes to the other offices. But he's flying from one to the other, so it's one-way airfare, and he only has $750. So we need to get him through all of the cities and back home for $750 or less. So, we're going to draw a picture. Actually, we're going to draw a picture more spaced out than that. Okay. He can fly out from A to any of these initial cities. And then from whatever city he goes to, he can then fly to the other cities. So these are all the possible routes he can take. Okay. Now, looking back on the chart, which you guys don't have to do, if you go straight from A to B, that's $180. From B to C is $116. From C to D is $169. From D to E is $194. This is $128. This one's $114. That's A to C. This one is $147. This one's 115. Whoops, I lied. I do that sometimes, sorry. E to B, 195. A to D is 147. And A to C is 114. And B to D is 145. Okay, so we have our starting city A. What city is it cheapest for him to go to? Well, from A, he can go to B, which is 180, to C, which is 114, D is 147, and E is 128. So A to C is the cheapest. Okay, now he's at C, which means he can go to B, E, or D. To go to B is 116, to go to E is 115, and to go to D is a 169. So it's cheapest to go to E. And then from E, well, he can't go back to A yet, right? Even though that's the cheapest. And we've already been to C. A, we have to wait till the very end. So my choices are B or D. 195 or 194? 194. So we've been to E, and now from D, the only city we haven't been to is B. So we have to go there. And then from there, we go back to A. We've made a full trip. And then we have to check and see if that is actually cheaper than $750. That's a 4. And if you add that all up, you get $748.
Just pay him the $2 then.